going the other way around, right? So we went from the table to the classes. How about classes to tables? So the algorithm might be a little bit the other way around, right? Where basically for every class that you have, right, you're going to generate a table, right? So from T1, T2, you're going to generate tables T1 and T2. So where choose a primary key. Notice that over here, we lost the fields for primary and foreign key. We don't have them anymore, right? So we don't have to go back here and generate those artificial keys because we don't have any of those keys in the class diagram. They're gone, right? So depending on whether we're looking at weak strong or weak or strong weak or whatnot, so on the strong side we're going to put the primary key, right? And on the weak side we're going to put the foreign key, right? So basically it's like a reverse algorithm, right, to go from class diagram to tables. So for instance, if you apply it into our really simple UML class diagram, you would end up with the original tables that we started with. Now, after we do this, we can start doing some optimization, some cleaning up here, where we might decide that certain things are irrelevant, right? If we, for instance, if we know that the courses, the title of the courses are unique across the university, then there's no point in having the artificial key CID, right? We can just keep the title, okay? If we know that we have a business rule that where student ID and section ID need to be unique, then we can make that into a composite key. And if that makes it unique, then really we don't need the primary key EID, right? So once we've run the algorithm, we might clean it up a little bit. Excuse me. All right, so let's clean it up a little bit. So for instance, try to identify what natural keys there are that we don't need some of these fields. So for instance, if we know that the department is unique across the university, there's no point of having this artificial key. So we eliminate department ID and just keep D-name, but that means that there's a whole bunch of other records in other tables that are referring to his primary key. So we need to go back in the students and re-update. Instead of major ID referring to that primary key, it's going to refer to the name of the department that they belong to. Same thing with a permit. Since there's a one-to-one relationship between a permit and a student, there's no need to keep them both, the unique permit ID. Since only one student can have that one permit, might as well just use student ID as its primary key and foreign key as well. A couple other things: the enrollment. Since we already have uniqueness between the student ID and the section ID, we can just create a composite key out of that, and we won't need the enrollment ID anymore, right? We can just create this composite key between those two that makes it already unique in the database, and also enforces the business rule of enrollment. A couple other things. Same thing. The course is unique. So we can just keep the title and refer to the department name. Same thing for the section. We can just use the title of the course, right, as referring to the from the section. There are limitations, right? It can only deal with strong weak relationship. It doesn't deal with many to many. It doesn't deal with a whole bunch of other things that we'll see and deal with them. Yes. Yeah. Right. The course ID, sorry, the department ID is already guaranteed to be unique on the department table, right? And when I select the department name for a particular student or course, I can those values can only possibly come from that table, right? If it's anything else, if I misspell it or whatever, the database will stop me. It will not let me do it. It has to be that value from there. Typically, what the user interface might be that we have a drop down where we select the department ID from a list of valid values, right? So we would validate it on the front end, again on the middle tier, and then the database would also enforce that the possible values can only be taken from those primary keys. Yep. Yeah. So the algorithm, these two really toy algorithms are not complete. We'll revisit them and add more features to them. Designing. So basically, the designing good schemas, good relational schemas, basically boils down to designing good class diagrams, right? So the first step really is to get how do I design good class diagrams? Yes.
I just had a question that we're creating tables from the classes.
Yes.
So the access modifiers don't play a role.
You mean public, private, and things like that? Well, no, those are only useful for an object-oriented analysis and design, right? So certainly, again, depending who your audience is, if it's a Java engineer, then yes, they will want public and protected and whatnot. Plus, they might want a whole bunch of methods and whatnot, right? But if your audience is for data analysis, those usually would not be relevant. But yes, depends who the audience is. You might want those as well. Yeah, so as I mentioned earlier, the designing a good schema, designing a good database, basically boils down to designing a good class diagrams, right? And so how do we do that? So designing a good object-oriented, applying good object-oriented analysis and design practices. Typically, it all starts with the requirements, and there's a whole course on requirements gathering. OOD. I don't know if anybody took OOD. And usually it's the most vulnerable part of any project is deciding what it is that we're building. And since everybody has a different understanding of what it is that we are building, and it's the hardest part to agree what it is that we're actually building. But anyway, this first step of requirement specification, very, very important that we get that right. Also identifying, understanding that it is impossible to know all the requirements a priori. The requirements are indeed are going to change over time, and we have to just be ready to take it, to deal with those changes as they come. So first requirements specification where you identify who your audience is, what are their goals, what are all the use cases, what are all the data that we are capturing from, and this typically involves a bunch of lots and lots of meetings and with all the stakeholders from business, from the business, from folks that are actually entering the data, looking at a whole bunch of logs and the forms that they're filling out, looking at all this and gathering, how does the business work, understanding how the business works. So it's a very, very, very hard step. So that one step is, it's a very, very big step, huge step. At some point, you'll formally capture all those meetings in some preliminary class diagram that you will present to all the stakeholders, and there will be several back and forth feedback on whether that class diagram indeed captures what we are building. Typically, it'll be a naive class diagram at first, and it'll evolve over time. Yes. We'll be looking for some of the weaknesses in the class diagrams. There will be inadequate relationships, or redundant relationships, right? So there will be relationships that we capture that are not reflected in the original text, or there may be things in the text that are not reflected in the diagram, or vice versa. There might be some relationships that are redundant, meaning that if you remember in a relational database, those relationships are two-way. You can navigate from one to the other, as opposed to in Java, for instance, right? And so you have to be careful then wherever you have cycles in any diagram that you can navigate from one way and then you can navigate the other. Usually that's a flag telling you that there might be some redundancy. That you can usually basically what you want to avoid is if you're doing a query, right, with a select statement and whatnot, can you retrieve the same information with a different query? Ideally not. ideally there's one only one way that you can query, right? And by joining several tables, right, navigating between one table and the other, and there's no other way to navigate it, right, to retrieve the same information. Because if there is, that means there's a redundancy in your database, and you can have inconsistency. So you're looking for these things, redundancies. Also, take a look at any many-to-many relationship, week-to-week. Those need to be reified and converted into something that can be actually implemented in a relational database. And then find the attributes which you might decide that certain attributes are not worth their own class, but maybe they are. Maybe like for instance, we decided that professors were not important enough to warrant an entire class, right? It's just an attribute in some other class, right? That might be a good decision or not, right? Depends on what it is that you're modeling. So those decisions of whether something is a class or an attribute, there's a lot of discussion around that. This will be an iterative process, through 3 to 6 in any particular order, until you come up with a class diagram. So let's take a look at an example of this.